Well, it's definitely great to be here. Definitely a lot cooler than Saudi Arabia. So, as I mentioned, I just came back from one of the richest oil countries in the world, and here I am in Alberta, basically, once again, talking about electric vehicles. And this session I'm doing is for you guys. So if you have any questions about electric vehicles, I've tore apart well over 100 EVs. I bought about 65 destroyed, damaged, wrote off electric vehicles when I used to own the company called All EV Canada, which we sold to the Steel Auto Group. Steel Auto Group is one of the largest dealer networks in Canada. They own over 64 dealerships. And so I had access to a lot of information when I worked for them. Currently I work for Consulab, and I have my own business, Powered EV Consulting, which allows me to travel around the world talking directly with OEMs at factory level for EVs directly. So if you have any questions about electric vehicles, things you want to know about them, any kind of myths, things like that about them, or if you want to know anything, tricks and tips about them, definitely see me after, or even during our last little bit of the session, ask me any questions about it. But it's really exciting at this time of year because the integration of electric vehicles into your workshop is happening. It's here. And as said by the president of General Motors, they said that we'll see more changes in the automotive repair industry in basically the next 5 years than we've seen in the last 50 years. And that's so true with ADA systems, advanced technology with components, advanced materials, systems, powertrains, and so on. Is definitely increasing what we're doing here today and what you need to know about fixing vehicles, as well as even assessing vehicles. A lot of vehicles I was purchasing were wrote-off vehicles, damaged to a point that they were not they could not be put back on the road. And it's important to understand when you're looking at an electric vehicle is the intricacy of the electric powertrain and what it means to the vehicle. And we're actually going to look at that this morning. I'm going to show some of the things about electric vehicles, things that you need to know, as well as some of the things you can take away with you when you're working or you have an EV in your shop. Let's start off first off. These are not new cars. This technology is not new at all. It's actually well over, almost 100 years old as the electric motor came about. In 1900s, early 1900s, the Detroit Motor Company built 13,000 electric vehicles. They were in the race against gasoline-powered vehicles back then. Thomas Edison was the inventor of the DC charger. So it's like, once again, when somebody says all these new cars, these new EVs coming into our shops, they're not new. The same principles apply to the cars back in 1900s to today's vehicles. In fact, Claire Ford, Henry Ford's wife, drove an electric vehicle. From 1940 to 1930, she drove an EV because the same reason people like EVs today. They're easy to operate. Back then they had to crank the engines. They're powerful, and they were very reliable. And that's what dominates the EV market today. The same things there. Very powerful cars, very reliable with very few moving parts in the powertrain. And once again, they're easy to operate. So the technology is not new technology, but we're seeing the transition further into our vehicle lines as we start to continue with EV integration into our networks. And as we see populations growing with the EVs, especially with incentives and so on, we're seeing more and more of these vehicles coming into our shops. And this is where it starts into what you need to know. So once again, I just came from Saudi Arabia, and like I said, it's a very oil-rich country, lots of money. $42 billion the government is investing into 2 factories over there to build over 600,000 EVs yearly for export, as well as import too within their own areas. And they're seeing that transition for renewable energy. They're seeing that transition for electrification. They know it's coming, and the government is the ones that are investing in it. Tesla, Hyundai are right behind these other 2 manufacturers. Today, Lucid is announcing their mega factory that they're opening within the next 3 months in Saudi Arabia. So I was just over there. Seeing these facilities is unbelievable. And the transition, what's happening over there in Saudi Arabia, it's nothing like you would picture that you think of a country in the Middle East. It's unbelievable what they're doing over there, especially in cities like Riyadh and stuff. So once again, it's not a threat but an opportunity, because once again, it's opening the doors for new technology, to learn new systems, to learn, advances within the construction of vehicles and what you can repair. Vehicles are safer on the roads today because of our ADAS systems and so on. That means that there's more systems on the vehicle. There's more electronics. There's more safety systems installed. That means when a vehicle is involved in a collision, then they have more work to be done, more electronics. About 15 to 20 years ago, I remember going into shops, and helping them with scan tools, scanning airbag systems and ABS systems and so on. Today's collision shops, you don't see that anymore. They're doing it all in-house, pre and post checks on vehicles. They don't need to send those vehicles away. But just recently, down in our area, I know a lot of shops are sending electric vehicles away. They don't work on them. They don't know anything about them, and they're turning away that work. So that transition has to happen quicker. It's going to come through training and knowledge of these vehicles and what you need to know about how to repair them. And once again, you got to remember the customer base that's out there. Just recently there was a study done in Canada that over 80% of consumers prefer to use service repair facilities over a dealership to have their vehicle serviced. But in the same system, in the same study or survey, only 9% of the consumers out there believe that a service center outside of a dealership is capable of fixing their electric vehicle. So they believe that a lot of that training is being held by the dealer, and they have that. And once again, it just comes down to information, training, and knowledge in order to be able to fix these vehicles. So, and I'd like to go back to a little bit is that these aren't different cars. There's cars out there like the Kona that has a sister vehicle that is an ICE-powered vehicle. Usually it's just the powertrains that are different, the body panels, the construction, the subframes. In a lot of cases, they're almost the same. You have the same ADAS systems on these vehicles. Electric vehicles don't bring on technology outside of the powertrain, meaning that an ADAS system found on a Kona is the same ADAS system you'd find on an electric or a gas-powered vehicle. It doesn't really matter. And I know a lot of people I've seen and heard where people say, well, electric vehicles are too tech-savvy. There's too much tech in them. Really, it's just a battery, an inverter, and an electric motor, at the end of the day. They don't even have transmissions. These cars do not have transmissions. They have gear reduction units. They don't need transmissions. So, so there's less parts on these cars, and the technology that's built into them is just based on the manufacturers trying to attract people to a more advanced system, safer vehicle, and more entertaining vehicle to drive in some cases. So what about high voltage safety? And this is where it gets down into my world, is into the training and knowledge and so on. And one of the things that happens with high voltage systems is, yes, it's true. You should never, attempt to dismantle or, work on a high voltage system unless you have the proper training. No different than gasoline systems or airbag systems and so on. Remember when SIR systems were becoming a big thing, and we were trying to, get people used to handling airbags and how to carry them properly, how to store them properly, how to ship them properly. Electric vehicles is just another system that you need to have that training on to understand the high voltage safety. And a lot of times I hear as well about the battery systems, about the batteries in these vehicles and how much, how complex they are and how expensive they are, and, and they can't be serviced. And somewhat that's true. A lot of these batteries, you're not going to be taking them apart. You're not going to be rebuilding them. Like I remember even the Prius batteries, from back in 2004 and 2003, how many people rebuild them? By the time the battery wears out in one of those cars, the car's pretty much done anyways. You're talking cars that are well over, almost 20 years old now in some cases. So, so one thing about the high voltage training is, focus on the high voltage safety, as I mentioned in another presentation I did. Understand what high voltage is, how to test test it, what to look for, how to identify components. Do they carry? Do they store? And I'll talk a little bit about that in a second here. But those are the things that you need to know as a technician, how to properly, safely use your PPE. When do you use the gloves? When do you use your protection when servicing a high voltage vehicle? Do you need arc flash protection if you're doing a brake caliper service on a electric vehicle? And I see these things out there where they're talking about all these different types of PPE for systems that they may not even be touching. Typically when you're doing a high voltage service disconnect on a vehicle, you're just breaking the power pack's voltage down. You're just splitting it in half or changing the voltage in that vehicle. But knowing how to do that properly and then knowing how to test it after is very important. So these are some of the things that the training that you need to know. So learn how to use your meter. You learn the fundamentals of high voltage systems. Know where to test, know how to test it, and use your equipment properly. And that's a big foundation of electric vehicles. I've worked on all different types of electric vehicles. Obviously the new Hummer that's here and stuff I haven't had a chance to get at, but there's a lot of the other ones that you will see mostly in your shops, especially Teslas. And one thing we're seeing with vehicles nowadays, I'll wait till the next slide, but just to give a little pre into it, is the connectivity of these vehicles. Where your phones and now become the key fobs, or, the systems that they put on apps on the phones where it allows somebody to control their vehicle remotely. Currently, I can go into my vehicle right now that's sitting in Halifax, Nova Scotia airport, and I can start my car. I can roll down the windows. I can turn on the climate control system. I can look at the 360 view cameras around the vehicle. I can unlock the doors on the vehicle. And that's a concern for repair facilities. If you bring a vehicle and it has that connectivity and the car's been sitting there for a couple of weeks and then the consumer is at home going, I wonder how my car's doing. Flip, flip, they're onto it. Meanwhile, somebody's working on the car and you just turned on the climate control system when you did that. And doing so, now it poses a hazard. That vehicle wasn't supposed to turn on. You have the key for the car, but somebody remotely has enabled the vehicle. So you have to know how to disable those systems, how to properly power down the vehicle so these things do not happen. Imagine being in a spray booth and somebody turns on the climate control system and the fans are on high and the battery cooling system kicks in, and next thing you know, you have this airflow happening around the vehicle as you're either prepping the car or you're applying your paint on the car. So these are some of the concerns that can happen with this remote connectivity. Is it just for EVs? Absolutely not. This remote connectivity can happen with ICE vehicles as well. But does it happen more on EVs? Yes, because there's a preconditioning that happens with electric vehicles that you can actually, do these things too. So it comes down to, where do we start? So this is a big part of, vehicles. I've had some vehicles that were pretty much mashed up into little paper balls, and it's pretty, but where do you start? That's the big question. If you have a vehicle so badly damaged that it's a total loss, it's got to go somewhere. Somebody's going to get this vehicle, and at this point it was me that got this vehicle. I didn't even see it before we got it. But first thing I did is I had to make sure it was safe. And how did I do that? I made sure I had the disconnect done on the vehicle. I tested for voltage from the battery, out of the battery to the systems on the vehicle. And then at that point, I knew it was isolated. But one thing that is brought up a lot about electric vehicles, I'm going to run through some of the misconceptions about electric vehicles. If I took my hand and put it on the positive contactor of a 400 volt battery and that vehicle turns on, do you think I'd get electrocuted if my other hand was touching the chassis of the vehicle? And why wouldn't I be hurt from doing that? Because of isolation. The vehicle battery is not part of the chassis system on the vehicle. It is completely isolated, and it's always being monitored. If I wound up with a fault between the battery and the chassis, it automatically hits an insulation fault. And at that point, the system is shut down. And even if I was touching, I happened to power on, the ground isn't attached to anything. And even if it was, it would blow the fuses on the vehicle, or once again, it would hit a high voltage insulation fault on the vehicle. So the manufacturers have built so many redundant safety systems into these vehicles that makes them very, very safe. In fact, if the vehicle was submerged underwater, and you're around the vehicle, once again, the battery is isolated from the chassis of the vehicle. Even if the battery is soaked in water, because it got water into the battery, touching the chassis of the vehicle is not going to electrocute you, because it's independent from that chassis of the vehicle. So once again, there is concerns around high voltage, and not saying that you should ignore or disrespect the high voltage systems, but understanding what the manufacturers have done to these vehicles with their redundant safety systems. And don't get me wrong, these voltages in these cars can kill. They have that capability. But you got to remember, most electric cars have the energy density in the entire battery to 2 gallons of gasoline. 1 gallon of gasoline is about 33 kilowatt hours of energy. Most electric vehicles are around 60 kilowatt hours of energy stored in their batteries. So 2 gallons of gasoline is equivalent to one vehicle's electric battery. There's more energy in gasoline than there is in battery storage on a vehicle. So some of the things that we have to be aware of is, understanding the components on the vehicle. What do they do? How do they work? What is their function on the vehicle? And if you're assessing or looking at a vehicle, what are components have been damaged? Now, most times in a vehicle that's involved with a collision, when the airbag goes off, it blows what we call a pyro fuse in some vehicles. Others, it will shut down the high voltage system. So it automatically has safety systems in these vehicles in the event of a collision that has deployed an airbag, or basically a restraint system on that vehicle. So once again, it's understanding how these systems work, but I say the best thing is always test before you actually go at that vehicle. So test is important. And also do it properly. There's a thing we called a live test. When you're dealing with electric vehicles on high voltage, you want to make sure you have a good multimeter that's at least a Cat 3 multimeter, and you also make sure that you test it properly. When you go to test for high voltage in a system, check a 12-volt system first on a good battery. Make sure it can read, and then test for voltage on the high voltage side of it. If there's no high voltage there, then retest the 12-volt system. This ensures that your meter and leads are reading correctly when you test a high voltage, and at that point, when there's no high voltage or there's less than a lethal amount of high voltage in that system, then you can proceed to wear your regular natural gloves or your nylon gloves and continue to do repair service on the vehicle. You don't need to wear the high voltage gloves once you ensure there's no high voltages there. So what do you need to know when you're looking for training and so on? I've done several different courses on electric vehicles, training from anything from drive units to charging to EV safety and repair and so on. But the thing is, the biggest thing, like I said earlier, is the safety aspect of it. Understand high voltage, understand how it works, what it does, understand the batteries and where they are and what they produce. You don't need to know about how to tear a battery down and rebuild it. I guarantee you, if you're in a collision and the battery case is damaged in any way, that vehicle is written off. There's the most times it will write the vehicle off because of the cost of the battery in some cases. But if there is a vehicle involved in a collision and you're looking at it and you're trying to determine if there's issues with the battery information is available on scan tools. And I'll tell you right now, if there's a cell that's been damaged or there's any damage inside the module itself, you can see it with the scan tool through the resistance, the voltage, min-max on the battery cells. Almost all the packs within a module are being monitored by the BMS. And the BMS is the battery management system that all electric vehicles have. So once again, if you're in a vehicle, if you have a vehicle comes in, it's heavy in the back end, and you're questioning if the battery is damaged or is it shifted, scan tool, go into the BMS system, look at the cell module, the voltages, the resistance of each of the cells within that module itself. If there's no physical damage and the battery's in good shape, the battery probably didn't take any effects from that collision at all. If there is a question about a vehicle that has damage on the battery, especially if it just came into your yard, there is protocols in keeping the vehicle away from other vehicles and buildings about 50 feet away, ensuring that the vehicle is not going to cause collateral damage if the battery happens to short while it's sitting. And it's true, they are energy units, they store that energy, and over time they can, if there's an incident within the construction of the battery, they can short and so on. But it's so rare. It is unbelievably rare if that ever happens. So you gotta remember, these manufacturers have made these battery modules impact resistant and damage resistant that they can survive pretty much almost any kind of collision. In fact, they have an IP67 rating, which is basically ingestion and as well as penetration 67, which is for water and other things to get in the batteries. In fact, some batteries actually have to be pressure tested or vacuum tested in order to before they go back into service. So once again, manufacturers have made these batteries so they're sealed. And how does a battery catch on fire when it's enclosed? Because lithium, when it burns, creates oxygen. And that oxygen fuels the thermal runaway within the battery and heats it right up. And I always tell people, lithium does not burn. I work with Dalhousie University at the RESL lab on some of their testing on batteries. They have a battery cycler there. And once again, it's amazing. Lithium just gets really, really, really hot and ignites everything else around it. So we see a lot of that, you see a lot of that when we talk about thermal runaway. It's not that the lithium burns, it actually it heats everything up. That's why when a battery has caught on fire and it's going to be recycled, they still can capture the lithium out of that battery, which is really easy. So once again, the other thing is making sure when you're doing any kind of service work on the vehicle is know where the disable procedures are, where that safety disconnect is. And this is only used when you're dealing with high voltage systems. So if you're doing a panel repair on a vehicle, or you're replacing the trunk and back bumper cover, you probably don't have to disconnect the high voltage service disconnect if you're not going into the high voltage system. There's no need to. The only thing is just make sure the car is powered off and make sure that the connectivity is not available to that vehicle. In fact, Tesla, if you get a Tesla in your shop, how many people drive a Tesla here just by chance? Anybody ever work on a Tesla? A few? Okay, great. Okay. So when a Tesla comes into your shop, what you should do is go under, at the very bottom of the corner of the screens, whether the S, X, or 3, or Y, on the very bottom left corner of the screen, there's a little picture of a car. Push that car. It's going to come up with a menu. Go under software. It'll show Model 3, Model Y, Model S, or X. Put your finger over the 3 and hold it. Put it over the Y and hold it. The screen will glow for a second, and then it'll put it into service mode. And what that mode does on the Tesla, it disables access from the phones. So it cannot be used, your phone cannot control that car anymore. And it's used by the service centers for Tesla and so on to put the vehicles in a service mode that allows the vehicle not to be accessible by the customer. The vehicle can't be driven over 15 kilometers an hour, and there's certain other attributes to do with that system. It puts you into also an area where you can do testing on the vehicle. If the vehicle's involved in a collision, let's say once again rear collision, you're wondering if one of the sonar sensors in the back is working, it'll actually test them for you. It's very graphical, it looks really cool. If the battery is, you want to check the battery, degradation of the battery, it can be all done through this service mode. This is just an example of what the manufacturers are incorporating into their cars. So if you're servicing a Tesla, it comes in, and I'll tell you, disconnecting the 12-volt battery on a Tesla does not turn it off. So, in typical cars we were used to, you disconnect the 12-volt negative cable off the Tesla, And and you think, oh, it should be off. The car still runs. You can actually drive it with no 12-volt battery in it, and that's because the DC to DC converter is powered off the high voltage battery. And as long as the converter has been turned on initially, that car will run without its 12-volt battery in that car. So it's something to be aware of. If you disable the 12-volt system on the car and the car doesn't shut off, then you have to follow the power down procedures for the high voltage system and to ensure that the vehicle is now disabled. If not, the vehicle will still be on. So just like in the old days when you disconnect the battery with the car running on an ICE-powered vehicle, the car continues to run because the alternator is still allowing 12-volt power through the circuit itself. Okay. I'll get into here. So what's next? What are we looking at next right now for moving forward? And one of the big things is seeing how much is coming out with electric vehicles. Installing charging stations at your facility is going to be a number one thing. They're not expensive. You can pretty much get a charger for your building for a very reasonable price. It's not a high-powered system. In fact, just let you know, I should back up a second. This is not a charger, by the way. So one thing you're going to take away from today is these are not chargers. They do not charge the car's battery. They are glorified extension cables. They communicate with the vehicle's onboard charger. The chargers for an electric vehicle are built into the vehicle, from the Hummer to the Ford to the Cadillac. The chargers are built into them. All these do is they supply the AC power to the charger, and then it's converted to DC power to go into the vehicle's high voltage battery. It's just like in the early days when we used to take the trickle charger. We plugged it into the AC wall. We had our charger and we put it on a 12-volt battery. And if we charged at 2 amps, that would be level 1. If I turn the charger to 20 amps, that's level 2. If I take booster cables from one car to another car, that is DCFC, direct current fast charging. So, and that's essentially the same analogy that that we use in today's charging. So level 1, level 2, basically you plug it in an outlet, 120, 240, you plug it into the vehicle, the onboard charger charges the battery. If you take booster cables, boost another car, that's like going to a supercharger and charging the battery. It's very fast, it gets the energy into the battery, but it's harder on the batteries themselves. So, and that's a little bit, so having these switch boxes, I call them chargers, so, but having these chargers on your building will ensure that you can keep your cars, because as a car sits for a period of time, electric vehicles don't like to sit. They like to be used. The energy in the battery likes to be used. So if the vehicle is sitting, it's going to start depleting that power from the battery. So it's good to have a charger on the building that you can actually top up that car's battery for, especially when the customer comes back after, maybe a week, 2 weeks, 3 weeks, or however long it's there for. And then they can leave your shop with a full charge on a battery. As well as having the proper PPE. Can't stress that enough. With the proper training and the proper safety equipment, you can do pretty much, and with information too. I call it the triangle of success. Having the service information, the tools, and the training. If you're missing one of those three, it's very hard to do a vehicle. You can have all the training in the world, all the information in the world, but you don't have the tools to do it. You could have the tools and the information, but you don't have training on it. So, having 3 of the pillars allows you to be able to do whatever repairs on the vehicle that you need to do in order for a successful repair on that vehicle.